Okay, guys, I will solve the last question again. We didn't complete it. I will repeat it for you. We will try to find the minimizer of this function with starting point 1, 1 by using the Newton's method. Newton's method requires to calculate the inverse of the Hessian. So we obtain the gradient of the function. As you see, we obtain the gradient and we obtain the Hessian. And we need to check that our Hessian must be positive definite. We checked it. It is always positive definite. So we can go on. To find the inverse of the Hessian matrix, we need to apply elementary row operations technique. If you know any other technique to find an inverse, then you can apply this technique also. We begin with A and I, and then we convert A function to I, and we obtain A inverse instead of the I function. So we began with A and I function, we do some elementary row operations, then we found the inverse of the Hessian. Okay, so let me remind you the formula for Newton. This is the formula for Newton method. Okay, so we will apply that. We have the x0 point. Let me write it. We have x0 point as 1, 1. Okay, and our x1 point by using this formula will be x0 minus the inverse of the Hessian. We write it here, 1 over 3. Let me write it, 1 over 3 minus 1 over 6 minus 1 over 6 and 1 over 3 times Hessian times the gradient. What about our gradient? We didn't calculate our gradient. Let me write